Okay, so let's go back and see if we can actually get a grasp of these logarithm things. Okay, so we said here that the logarithm is the inverse of the exponential. The exponential would normally look like y equals, the output is equal to 3 to the x, or something like that. So you're inputting the exponent, so x is an exponent, and y is the answer that you get when you use that exponent. Well, the inverse of this means that x and y switch places, just like they have here. Instead of having an x up here, we now have a y up here. Instead of having a y over here, we now have an x over here. So that means that the exponent is now the output, or the thing that we're going to get, and what we're going to put in is the answer. So we put in the answer, and we get out whatever exponent is needed to make it. Okay, so here we go. We put in the answer right there, and the output is whatever exponent needs to go here to make it. So here's me using this. I put in the x. Let's say I put in 27. Okay, now I know that 3 to the power 3 is 27, so that means that the log base 3 of 27 is 3. Because remember, I'm putting in the answer and I'm getting out the exponent, and I'm calling that process the log. So I start with the answer, I get back the exponent. Okay, that even seems weird to me. Okay, so let's go over here. Let's go over here and look at this. So you've been told that if you have a statement like this, you can rewrite it like that, and this always works every single time. So you have this is telling you the base, this is what goes as the exponent, and this is the answer here. So 3 to the y equals x. 3 to the y equals x. Nice. So let's use it right here to solve this. If we want to find what this y is, then we can rewrite it in exponential form. Okay, base is 3. Exponent is what we're looking for. That's y. And the answer to all of this is 9. Now you can think it through and say, oh, 3 squared is 9, so y must be equal to 2. So I can have 3 to the power 2 to get my 9. So that means the log base 3 of 9 is equal to 2. Can go again here. Okay, base is 3, exponent is y, and the answer is 81. So 3 to the what equals 81? Well, let's think about that. I know 81 is 9 times 9, and I know this is made up of 3 times 3, and that's 3 times 3, so that means that this is 3 to the 4. So the exponent I'm going to need on my 3 to make 81, which is 3 to the 4, is a 4. So y equals 4. So the log base 3 of 81 is 4. Now let's look at this statement right here and see if we can make sense of it without going back to the exponential. So we know it involves exponents. This is the base, and that's the answer, and this is the exponent. So I can do kind of a little trick here. Let me just change colors to do this. I can say that, hey, this number that is the log, because the log of this is that, so this is the log, it is the exponent. So let's just write that down. Log, a log is an exponent. Of course it's a number, but it's a number that gets used as an exponent. A log is an exponent. So what does this exponent go on? Well, it depends what kind of base you have. Here the base is 3. So that means this 4 is going to go on the 3. So 3 to the 4, and this is the answer, equals 81. Like that. Okay, so 3 to the 4 equals 81. Oh, that means the answer, all this is 4. So basically, when I see an expression like this, what I'm trying to tell you is, time for a different color. Okay, so let's just look at this. Instead of rewriting this as an exponential, 3 to the y equals 243, okay, which I can do, let's just ask ourselves, 3, I'm trying to figure out what exponent will make this. Well, what do you mean what exponent? Oh, what exponent do I have to write on 3? What exponent goes on 3, so fills in this spot right here, to make it equal to 243? Well, it turns out, let's take a look over here. We know 3 to the 4 is 81. And if I take 81 and multiply it by just one more 3, I get 3 times 8 is 24, and 3 times 1 is 3. So that being 4 3's and one more 3, 3 to the 5 is 243. So 3 to the what is 243? 3 to the 5.